Yo, what up fam? Kevin here. Welcome back to Yerkit Racing. Today we've got an exciting video for you as we dive into upgrading the spindle on our AnoleX 3030 Evo Pro CNC machine. AnoleX has sent us out their 1.5 kilowatt spindle, and we'll be comparing that to the stock spindle that came with the machine. Let's get started. So first things first, let's unbox the AnoleX 1.5 kilowatt spindle and see what we've got. Now obviously I've taken the foam insert out of the cardboard box that it came in and went ahead and took some of the plastic off of the stuff just so it would make a little smoother transitions for the video. But to start with, just like the machine when we got it, the 1.5 kilowatt spindle comes with a very nicely done set of instructions. After that, we have our two ER11 collets, 1 1/8 inch and 1 1/4 inch. This will not come with the kit. You will need to purchase it separate. It is the 65 millimeter spindle holder kit. It comes with a adapter plate and also the hardware for it. Like I said, that will have to be purchased separate. It does not come in the box. Outside of that, we've got our power supply and cables. This here is our controller for the spindle. Comes with a couple of wrenches. Even the mount itself comes with very nice instructions. And last but not least, we have the AnoleX 1.5 kilowatt spindle. So that's everything that comes in the box. Again, really well packaged, as you can see. Really thick foam around everything. The quality that we've come to expect from AnoleX. So now that we have everything laid out, we want to take a second to talk about the specification differences between the two spindles. This is a 1.5 kilowatt spindle versus the 300 watt 10,000 RPM spindle that came stock with the machine. This 1.5 kilowatt spindle boasts a 24,000 RPM rating, which will be put into the test during our review. Alright, so now comes the fun part, installing the new spindle. Be sure to follow manufacturer's guidelines and precautions. We'll be going through a step-by-step process of swapping from the old spindle to the new AnoleX 1.5 kilowatt spindle. Okay, so step number one is to make sure that our machine is turned off and disconnected from the power supply. Our next step is going to be to disconnect the factory spindle wiring and then remove the factory spindle. It's a simple just push type clip at the top, quick connect. Just push it down and it'll pop right out. And then it's as simple as loosening our 4 Allen head screws. Once we have the factory spindle removed, we will set it to the side along with the hardware. Okay, so as per the instructions, we will use the 6 Allen head screws in the countersunk holes to attach our adapter plate to the stock mounting plate. We want to get them good and tight, but be careful not to over tighten them, as we don't want to strip any threads here. I'm going in a star pattern. It doesn't specifically say to do so, but after working on a bunch of stuff, anytime you're tightening down something, it's better to go in some sort of, cross-directional pattern to make sure we get an even tight. Come back and check the first couple again just to be sure. Alright, everything feels good. We're happy with that. Attaching our spindle mount will be the reverse of how we took the other one off. Slide it up and use the 4 Allen screws to secure it to the mounting plate. Okay, that is our 65 millimeter adapter mount installed on the machine. The new spindle will install the same as the old. Slide it down into the housing, and then we will tighten our screws down to clamp it. I'm going to tighten the 2 outside first that are away from the slot. Then you can set the spindle height about where you would like it and begin to clamp down, trying to go evenly. Once you're happy with it, we'll move on to wiring according to our user manual. To give you a better look at this portion of the install, I'm going to spin the machine around, and this will give us access to our panel back here. To begin with, we will remove the cover from the panel. Start by loosening all of the screws on the corners, and then we'll just run them out, being careful not to lose them. Okay, once we have our cover out of the way, we will take our PWM cable from our supplied package and plug that into this black slot. Being careful not to bend anything. Should not be a forced situation, it should just go right in. With that portion in place, we should be good to install our cover back on our control board, being sure not to pinch any wires. With our cover reinstalled on the control board, we are ready for our control box, which the other end of the PWM cable will go into. Next, we'll need to make the two connections for the aviation cable as laid out in the user manual. I didn't see in the instructions where it clarified which end goes to what. For this particular set, the white end is going up to the spindle, and our black connector will go down here to the control box. With our aviation cable installed, the only thing left for wiring is plugging in the new power cord to the control box. The next thing we'll do is install our 1/4 inch ER11 collet. Okay, so now that we have our collet installed, let's check to make sure we have power going to the unit. We're going to start by switching the power on the back of the box. As you can see, the LED has lit up indicating we do indeed have power. We need to turn our emergency stop switch to the right to make sure that it is not set. And then we can use our speed knob here to adjust how fast the spindle will run. Now that we've verified having power to the control box, I'm going to hook the computer up and see if we can get it to run. Alright, so we got our computer hooked up, we've got candle pulled up as the program. We're going to get ready just to send a spindle on signal and make sure that that part works. We're just going to turn the machine on with no emergency stops in place. See what happens. Okay, so there we go, we got action. Now this knob here, we're supposed to be able to spin it and turn it down, and we should be able to turn it like that right there, where it go all the way down as low as we want, where it's barely turning. 136 RPMs all the way to 24,000. So we have complete control of our spindle with this knob. 24,000. All right, emergency stop. Power that off. With the new spindle installed, it's time to put it to the test. We'll run a few sample products to compare the overall performance of the AnoleX 1.5 kilowatt spindle to the stock one. We are looking for improvements in speed, precision, and overall efficiency. Alright guys, so we're getting ready to cut the soft jaws for our pointer to be able to sit in so we can machine both sides of it. Let's see how it cuts now. This will be 60 inches per minute, 10,000 RPMs. 0.25 millimeter step over and 0.25 millimeter depth of cut. This first file that we're running, guys, is an old one from another video that we posted a couple of weeks ago where we first cut the soft jaws. This was with the stock spindle and the 1/8 inch bit after we had had some time to play with it and speed everything up, kind of trying to optimize for what we had. Take notice of the small dust particles and relatively slow cutting. I mean, this thing took us about 3 hours to cut out this way. Okay, so we just finished the soft jaws, and this is the 3D printed timing pointer that we had done to test. Everything fitting up very nice there. Really happy with that. Okay, so next up we're going to be running our 1.5 kilowatt file with our 1/4 inch end mill. This will be with the AnoleX recommended settings and conversation. We thought we could get to 1 millimeter step over, 1 millimeter step down, and about 40 inches a minute is where we would start at. Thought that that would be a good point, so fingers crossed. We're gonna give it a shot here. Let's see how it goes.
Okay, so it's working good at 60 inches a minute. I'm gonna go ahead and step it up again over in the computer. The max I can override it is at 200%. That'll get us to 80 inches a minute. Let's see how it goes. Okay, I think it's safe to say everything was going pretty good, except for our work holding has failed us yet again. It's just too much force for the vise, I guess, that we have here. It just won't hold it. Okay, so it did good at 60 inches a minute, but that right there was definitely a fail at 80. With that being said, I know some of these other files that I already have drawn up here to try are going to be a problem, because one of them was 3/4 of an inch deep, or capable of going 3/4 of an inch deep at 120 inches a minute. Obviously that's not going to work for this setup. So next, I think I would like to slow the speed back down and get a little deeper cut. Maybe we'll try that. Okay, so I actually figured out that for some reason I thought I had already pre-tightened everything to where it would be good to go, but I had only tightened this block, and this one I hadn't actually ran the screws down to tighten, so hopefully that will fix our problem. We're going to try to run this thing again and see how it goes. Like I said, hopefully that'll be it. Man, guys, that is absolutely insane. Took us all of about 9 minutes to cut this thing. Absolutely unreal. This thing is flying now. The 1/4 inch bit and the new spindle, definitely the way to go. Still got some improvement we're hoping to make here. I'm gonna get ready to run another file that we have that goes even deeper with one pass. A little bit nervous because I really am happy with where we're at now. But for the sake of knowing how far we can push the machine, we're gonna give it a shot. I'm gonna go cut 2 more of these blocks and we're gonna run it that way. Let's see how it goes. All right, so we had good success with the last one. I'm gonna get ready to run the new optimized file for the 1/4 inch end mill. Now this is a much more aggressive cut. Definitely a little nervous. I'm gonna override it at like a 10% because it's like 127 inches a minute that this thing wants to run at for optimizing the tool. Not sure the machine can take it. So like I said, I'm gonna back it way off. I'm gonna start at like a 10% rate of feed, and then I'm gonna ramp it up hopefully to the 100%. Let's try it. That ain't it. That is not it. Safe to say that we're not going to be cutting it that fast. So it was kind of working. I hesitate to say exactly what the problem is. I don't really know. I do know that we flung out a couple of rather large chips. So I mean, it was kind of working. I don't really know at what speed it went wrong. However, I'll say, you know, just kind of based off of what I'm looking at and the way it sounded was about the time it went from ramping in, which was that slower speed, to hitting the wide open speed brake. See if you can hand me that other piece wherever it flew to, right over there by the wall. by the time it hit that, it really didn't even get into this piece hardly. Just kind of threw it out. But anyway, by the time this thing ramped up to the full speed, it did not like it. I do think though we were getting a full depth cut at our about 40 inches a minute. I'll have to look at the file again to see how fast that thing was ramping in just then. Let me go do that real quick. All right, so I went back and looked at it, and obviously the last one didn't work. It jumped out of the vise, which I think is our limiting factor here. That's the amount of clamp force that this little aluminum vise can actually put on the part. And I want to say it jumped out right about 90 or 100 inches a minute, which I know is pushing it anyway, but like I said, the tool optimization chart was showing us somewhere in the 127 inch per minute for like an industrial machine. So my best guess is that's the factor, is the actual clamp force on this little vise. I went back using the same step down and the same optimal load, but reducing it to a 40 inch per minute feed as a max out point to kind of start there, and then I'm going to ramp up the rate to probably 60 or so. We'll kind of play with it, see where we can get to. Anyway, let's try it. Alright, well again, that is a fail at that depth. I mean, possibly again it could have been clamping. I really still think that this thing will actually cut it like that. It started out doing great. I don't know, hopefully it got it on the video. I'm not sure if I hit the record button or not that time. But it started out doing great. You know, we were making these really big chips, you know. And all of a sudden it just decided to kick it again, and it got kind of bound up in there sideways, started jumping around and chattering. So the cut looks like crap, but it didn't start out looking that way. That basically happened as it was coming loose. I'm gonna slow it down again. We'll try again. All right, 40 inches a minute did not work. I'm reducing the rate down to 25%. That'll put us in the 10 inch per minute range at a full depth of cut of about 1/4 inch. Let's see how that goes. Okay, let me grab the vacuum real quick. That's crazy. Okay, so we had something funny happening here in the program. It did cut it, and cut it pretty well. However, for some reason, in the center was the right height, started getting deeper as it got to the edge over here, and then really got deeper where, I mean, it's like, that's almost to the bottom of it. That's over a 1/2 inch deep cut there, and it was still cutting it. I mean, obviously it started making more noise, as you could hear, and not ideal, but I ended up ramping the speed up to 50%, which would have been 20 inches per minute up through this portion, and it did good. So anyway, we got to see that it ran the whole file just then, even though it was kind of jacked up and not exactly what we were looking for. It took it 7 minutes and 1 second. So we know it's possible to cut at a really good pace with this machine. Still got to play around with it to find that perfect feed and speed, so that's what we're going to do. But at least now we got a reference point for what we know it can do. I just got to figure out what happened with that file, why it cut weird.
All right, so I looked at the bit really close, and it looks like you can see some swirl marks where it's kind of worked down. I had it set really close to this line right here, and I'm guessing maybe we just didn't have our collet tightened enough, and it has just slipped, and that's why we got this really deep-sided effect over here. Like I said, that last cut over here on this side especially was very deep, well over probably a little over 5/8 of an inch deep over there. Quite a deep cut.
Anyway, I'm thinking that's the problem, so we'll just reset the bit up in the collet where it needs to be at, and I think we'll be in good shape. That file there, it ended up at 7 minutes and 1 second of run time, and that was cutting at 50%. And that's where we were running it. If you see on the feed right here where I can override it, it's at 35 now. At one point, most of that cut there, we had it running at 50%. So
40 inches per minute is what the file set to. 50% of that would be at 20 inches a minute, and that was all the way up at 5/8 of an inch. At the 1/4 inch depth it was supposed to be cutting, it was actually very, very smooth. Very happy with where it was at. So we will probably end up running that file once again and see how it all goes, but thinking we're gonna like that. Okay, so I have reloaded the material back into the vise here, and we're getting ready to run the file one more time. I reset our tool in the collet and tried to snug it up real good, tightened the vise down pretty good. So really hoping that this time is going to go ahead and cut real smooth and give us the result we're looking for. Cross your fingers, let's see how this thing goes. Alright guys, so truly amazing. Can't believe how fast and awesome this thing is cutting. One smooth pass, full depth. Really couldn't be more happy with it. If we come back over here and we take a look, 4 minutes and 29 seconds total time for this file to run. Started out over 3 hours. Huge shout out to AnoleX for sending us out this new spindle, the 1.5 kilowatt. And being able to run this 1/4 inch bit has really picked up the pace, and it's going to get us where we're trying to go with it. Alright guys, so that's our journey installing the 1.5 kilowatt spindle from AnoleX on our 3030 Evo Pro CNC machine. Can't be happier with it, guys. Definitely, if you're going to be cutting metal, aluminum, go ahead and pick this thing up. It's going to save you a lot of headache in breaking bits. It's going to pick your machining time way up and generally just make this thing even more fun for you to get out and learn on. Huge shout out again to AnoleX for sending it out. Can't thank them enough. The customer service again has been nothing but awesome, and you know, if you guys are looking to get into a machine and haven't done it yet, I definitely recommend, you know, picking up a CNC machine from AnoleX and getting started there. Outside of that, make sure you guys go ahead and subscribe to the channel, turn on the notification bell so you can follow along with the projects we got coming up here in the future. I can't wait to see, you know, what we can end up making with this thing as we learn more about it. And I'm hoping, you know, at some point we'll be able to run some even bigger pieces. I just saw that AnoleX actually came out with another machine that's even bigger than the 3030 now. I want to say it was a 4030 Evo Ultra or something to that effect. Anyway, definitely wouldn't mind trying that one out at some point too. And yeah, man, just excited for where we're going. Go ahead and hit that bell. Give us a like if you enjoyed it. And we'll catch you guys on the next one. Thanks and God bless.